Working with rational equations. Okay, difference between a rational expression and a rational equation. Well, rational expression has a polynomial or a term in the numerator and denominator. And in this case, we're going to add an equal sign to it, which will make it an equation. So working with these rational equations, we want to be able to solve rational equations and determine extraneous solutions. Okay, my extraneous solution is a solution to an equation, that is not going to be a solution. So we may have solved and came up with a solution, but in the end, when we plug it back into the original equation, it doesn't work. So we'll do some examples there. And of course, we want to be able to use these rational equations to model and solve real-world problems and determine the reasonableness of the solution to the rational equation. Let's see, so as we work with rational equations, one thing we're going to have to remember is when we are working with fractions, if we have one fraction plus another fraction, how do we solve that? Well, in order to add or subtract fractions, they have to have a common denominator. So what would be my, denominator, right? What would be my common denominator between 2 and 6? Well, that would be a 6, okay? So my second term here, if my common denominator is 6, I'm just going to carry that down. That is going to be 1/6. But 2, in order to get my 2 to be a denominator of 6, what I have to do is I actually have to multiply the denominator and the numerator both by 3. So when I multiply 2 times 3, I do get 6 in the denominator, and then my new numerator will become 1 times 3, which is 3. So 3 over 6 is the same thing as 1/2. But now that I have a common denominator, right, I know that when I add these two things together, I'm going to get 3 plus 1 over 6, or I'm going to get 4/6. Well, 4/6 can be lowered again because I can divide both the numerator and the denominator by 2. Divide by 2, and that's going to be 2/3. So this equals 2/3. So just remember, when you're adding and subtracting, you're having to find a common denominator, because that is going to be very pertinent as we work with some of the ways to solve rational equations. So here, when I'm solving this rational equation, I have, as an example, 1 over 3a squared minus 1 over a equals 1 over 6a squared. And in order to, these are fractions, so in order to subtract these fractions, I am going to need to find a common denominator. And look at that, step 1 tells me find the least common denominator. So if I look at all of these, 3a squared, a, and then 6a squared, it looks like my least common denominator is going to be 6a squared, because I can multiply this by 6a, and that will give me 6a squared. I can multiply this times 2, and that will give me 6a squared. And of course, this is already 6a squared. So when I do that, let's go ahead and set that up. I'm going to have 1 over 3a squared, and I'm going to multiply the numerator times 2 and the denominator times 2 minus 1 over a, and I need to multiply the numerator times 6a over the denominator by 6a, because that's the value of 1, right? And then equals 1 over 6a squared. And that was step 2 right here. Step 2, multiply each side by the least common denominator. And does that show you that I multiplied by the least common denominator? Tell you what, let's back up one step. Let's forget we did that yet. All right? So multiply each side by the least common denominator. So I'm going to multiply 6a squared times 1 over 3a squared minus 1 over a. And then that's going to equal 1 over 6a squared times 6a squared. All right, so now what I've done is I have multiplied both sides by the common denominator. And I'm hoping we'll see here in a minute what's going on, because I didn't mean to skip a step. So remember, I'm going to use my distributive properties. So that is going to be 6a squared times 1 over 3a squared minus 6a squared over a, right, of course, times 1, equals 6a squared over 6a squared. Now, when I do some simplifying, a squared is going to cancel out a squared. 3 is going to simplify down, so 6 over 3 is actually just going to be 2. So minus my a in the denominator here is going to cancel out, and that's going to become a to the first power. And then the 6a squared divided by 6a squared is just going to become 1. So that is going to equal 1. This is going to equal 6a times 1 over 1. And this one is going to equal 2 times 1 over 1. And that is what I ended up looking like here. So I sort of skipped a step for you, and I wanted to show you where that came from. So now when I look at this, when I work this out, of course, get this out of the way now. Oops. So now that I've multiplied that out, I can go ahead and simplify, and I'm going to have 2 minus 6a equals 1. I'm going to go ahead and just solve for a now. So I'm going to subtract 2 from both sides, and I'm going to have negative 6a equals negative 1, divided by negative 6, divided by negative 6, and a is going to be equal to 1/6. So as I plug 1/6 back in, of course, that's the step 4, right? We never do that one. It'd be 1 over 3 times 1/6 squared minus 1 over 1/6 equals 1 over 6 times 1/6 squared. Goodness, don't you hate when this happens? So I'm going to have 3 over 36 minus, and I'm just going to leave it as 1 over 1/6 for now. Give it a second here. And then that is going to equal, that will be equal to 1 over 6/36. Goodness, craziness there. So it looks like, so it ends up equaling 12 minus 6 equals 6, and that is a correct statement because 6 does equal 6. You just gotta love fractions. Okay, so looking at using factors of -1 in a denominator, what we're going to do here is as we look for a common denominator, we do have two binomials. And you'll notice that I have c minus 2 here, and then I have c plus 2, and then 2 minus c. So very similar, but what I can do is this expression right here, I can multiply it by -1. And it is going to give me, multiplying it by -1, not x minus 1, right? Multiplying it by -1. So that is going to end up giving me a plus 1 over c minus 2. That's how that's going to change that. And there you go. I showed you the math over here to the right, multiplying the numerator and denominator by -1. Or the value of 1, right? It allows me to change that to a denominator now, which looks very similar to what I already have over here. Okay, so now I'm going to look for a least common denominator, and I guess let me go ahead and rewrite this. And a least common denominator is going to be c minus 2 times c plus 2. That would give me my least common denominator. And what I want to do is I want to multiply both sides by the least common denominator. So when I multiply both sides, as I look at the left, multiplying this across, if I just do the multiplication, goodness, to show you every step, is going to be c minus 2 times c plus 2 times c minus 4. All of that is going to be over c minus 2. Then I'm going to multiply, again using the distributive property, I'm going to multiply that by both terms. I'm going to have c minus 2 times c minus 2 times c plus 2, all of that over c plus 2, plus c minus 2 times c plus 2, and of course times 1, all of that over c minus 2. And doing it this way, what you can see is some stuff is going to cancel out, right? C minus 2 over c minus 2 is going to cancel out. C plus 2 over c plus 2 is going to cancel out. C minus 2 over c minus 2 is going to cancel out. So we end up with c plus 2 times c minus 4. And that is going to equal c minus 2 times c minus 2 plus c plus 2. Now we can do some kind of multiplying, right, before we can combine like terms. So when we use the distributive property, this side over here will become c squared minus 2c minus 8 is going to be equal to c squared minus 4c plus 4 plus c plus 2. This is that. This is that. All I did was multiply it out using the FOIL method, and if you need assistance with that, there's another video for you to watch there. Okay, and let's see here. So as I combine like terms, what I'm going to do is I'm going to go ahead and move my variables to the left and my whole numbers to the right. Okay, and then I'm going to subtract c squared. I'm going to add 4c and subtract c, right, to cancel those out. So that means I'm going to add 8 to both sides. That will cancel that out. And then, of course, subtract c squared plus 4c minus c. And what I have here is c squared minus c squared is going to cancel out. I have 4c minus c, which is going to end up giving me 3c here. 3c minus 2c is going to give me c, so c is going to equal, of course, this canceled out, right, became, those canceled out to move them to the other side, and that is going to be c equals 4, 8, 10. C equals 10. Or there's a good chance that I can't add because I have 8 plus 2 is 10 plus 4 is not 10 but 14. So C is going to be equal to 14. And you can plug that back into the original equation up here. Plug that back into the original equation and you will find that it does work and there are 0 extraneous solutions. And we'll talk about it here in a second. Another way of solving these is going to be using the cross product property. And what we can do here is, since we have, a rational expression, we can just go ahead and cross multiply. I can multiply that, and I can multiply that. So I end up having x minus 2 times 1 equals x plus 10 times x plus 3. And multiply that out. That would be x minus 2 is going to be equal to x squared plus 13x plus 30. I am going to go ahead and move everything over to the other side so I can use the 0 product property to solve. So minus x plus 2, and these will cancel out, making that equal to 0. And then I'm going to have x squared plus 12x plus 32. And so using my 0 product property, I'm able to factor that. And that should be x plus 4 plus 8, because 4 plus 8 adds up to 12. 4 times 8 multiplies to 32. So that's how I figured that one out. So x plus 4 equals 0, or x plus 8 equals 0. So again, inverse operations, x is going to be equal to negative 8, or minus 4, x is going to be equal to negative 4. Now with that, we have, so two possible solutions. If I put them back in here and check, they should work for us. That's always a big bonus. And let's see here, going on to the next possible choice. Oh, using a proportion. What we're going to do is very similar to what we did previously. But we're going to go ahead and make this into one rational expression on the left. And in order to do that, let's say, hey, it looks like the common denominator here is going to be 2x. So if I multiply the first expression by x over x, that would give me 1/2, right? Plus 1 over 2x is going to be equal to x squared minus 7x plus 10. So this left side became x over 2x plus 1 over 2x equals this same thing again. So when I combine that, I'm going to have x plus 1 over 2x is going to equal this same thing again. And now you can go ahead and cross multiply. You can do some simplifying, but tell you what I'm going to do is I am going to focus on getting rid of this 4x from the denominator. And by doing that, I'm going to go ahead and multiply both sides by 4x. And what that does, of course, this becomes 1. Rewrite this side, and here what it does is it simplifies a little bit. I have 4x over 2x. Well, that cancels out or simplifies down to just 2. So over here I have 2 times x and then 2 times 1, so that's going to be 2x plus 2. And I'm going to subtract them and move them over to the other side. Those will cancel out to 0, and that will become x squared minus 9x plus 8. And when I factor that, that is going to turn out to be x plus 8 times x plus 1 equals 0. And we know that using the zero product property, I have x plus 8 equals 0, x plus 1 equals 0. Minus 1 from both sides, x is going to be equal to negative 1, or minus 8 from both sides, x is going to be equal to negative 8. So there's my two possible solutions. Plug them back in, check them, they are going to work. But what is my extraneous solution here? My extraneous solution is something that will not work. And if you look at this, the number, the value that will not work here is going to be 0. I cannot have 0 in the denominator, or x cannot equal 0, right? X cannot equal 0, because if it's 0, then my denominator, this denominator would be 0, this denominator right here would be 0, and those would be undefined values. So that's my extraneous solution there. So that's what they're talking about when you have solutions that may not work. That would be a solution that would not work. So here, rational equations, of course, worried about the extraneous solutions and what really is a rational equation. How can you solve an equation containing rational expressions? Well, by eliminating the denominators using the least common denominators, or by using proportions. And this may seem daunting and a very long problem, but the more comfortable you are with fractions, the easier it is. So you may need some practice with fractions. But again, I showed you every step that you could make. Your knowledge may leave you making less steps. It's just a matter of, hey, I had to give it all to you so you can see where you need to work at. So again, we'll work with some rational equations and see how it goes.